So section 9.3 has been shortened quite a bit from previous years, so lucky you, you get the nitty-gritty version of this. So we have the polar and rectangular forms of equations, and we're going to transfer between the two forms. So I have approximately 15 minutes to get this lesson recorded. Let's see. So we are going to be converting between polar and rectangular, both directions. So this is going to look like a big familiar trig problem, right? We have what looks like a unit circle here, and when you graph an ordered pair, it's in the form cosine comma sine. So we're going to be using our knowledge of the unit circle today. And then remember, for polars are in the point r comma theta. So what they've done here is they rearranged an equation solving for the x-coordinate and solving for the y-coordinate. So if you have a polar coordinate, you can use these formulas to go to rectangular coordinates. So this is what we're going to be looking for when I want rectangular. All right, so on our notes, a lot of formulas here. You might want to do some highlighting. Here's those same x and y formulas for going to rectangular. And then the r, remember, is basically a Pythagorean theorem question. So x squared plus y squared. And this is kind of unique, though. To find theta, you're going to use inverse tangent of y over x if your x is a positive value. But you're going to use a little different formula if x is negative. It's going to be the inverse tangent of y over x plus pi. So just because we need the other reference, it's kind of like a reference angle, right? If you think about the way the polar line went for, I'm making this up, like theta equals pi over 4. Remember, it goes through the pole. So we have to remember that if x is negative, this is the formula we need for theta. Keep that in mind. All right, this question's already done for you, but we have a polar coordinate. So when they set it up this way, that means r is 3 and theta is pi over 4. So they would have jotted down some formulas on their paper somewhere where the cosine of 3 pi over 4 is negative square root of 2 over 2, and the sine of 3 pi over 4 is positive square root of 2 over 2. And they use those x and y formulas with these values plugged in. So see right here, the exact values, and then they simplified. So came out to rectangular coordinates of negative 3 square root of 2 over 2, comma 3 square root of 2 over 2. So this polar coordinate is equivalent to this rectangular or Cartesian coordinate. So find the rectangular coordinates here. So this is all on us. So r is 20, theta is negative 60 degrees. So the first thing I do is I jot down who sine and cosine are for negative 60 degrees, which you could just look at your unit circle, or hopefully you have something memorized, but since I don't want to mess up, I'm going to jot down, I'm going to look at my notes I jotted down. Cosine for this angle is positive 1/2, and sine is negative square root of 3 over 2. So when I go to fill out my new polar coordinate point, it is r times, so 20 times the cosine, oops, you know what, I already know this. Wasn't the cosine 1/2, didn't we just say that? Comma, and then r times the sine, which we said was negative square root of 3 over 2. Of course, we're going to want to simplify this. We get, let's see, that's 10, comma, that reduced to a 10, so negative 10 square root of 3. So here's our our rectangular coordinate off of this polar coordinate. All right, number 2. Here's our r, here's our theta. So I'm going to jot down who cosine and sine are. Cosine of 5 pi over 6 is negative square root of 3 over 2, right? Yep. And then sine is positive 1/2. So going into my new rectangular formula, I have negative 1 times the cosine, which is negative square root of 3 over 2, comma, negative 1 times the sine, which is 1/2. So simplifying this rectangular coordinate, we get positive square root of 3 over 2, comma, negative 1/2. Awesome. So those are pretty simple. I'm going to skip these next two because they're the same, so they're pretty boring. Let's move on to finding the angle next. So here, we're going to be giving you rectangular coordinates. And this discusses why you have to do the theta plus pi, because we need the other side of that ray, or the, I don't know what you want to call it, but the line. So that's a good description of y, but for the sake of time, let's just trust me when I tell you you need to use those formulas if x is negative. And then if x is positive, then we're good to go. All right, so this is on your notes, I believe. It's kind of in a weird order, though, so let's go ahead and look. You got to back up in your notes a little bit. These are rectangular coordinates, so good old-fashioned rectangular coordinates. So 5, negative 9. Go back here. And then what they did is they set up this formula to find r, which is pretty basic. You can either leave it as a radical or an approximation. And then they set up the inverse tangent of y over x. But this is in radians, remember, for polars, so radians. I mean, the formula we've been using has pi. If you choose to do it in degree mode, that's fine. Just instead of, just remember you're in degree mode, I guess, and label accordingly. So when they type this in the calculator, they get negative 1.06. So this is a great answer. However, it does say a second polar. Can we jot that down for a second? So, oh gosh, I should be able to draw this, right? I'm not going to draw out 10 rings, but negative 1.06 radians would be, oh, I don't think I sketched this for myself at all. Here's the idea, guys. Remember that line where they were like this, and they said you could add a pi and go backwards like this? That's what they're talking about. So what you can do is say it's the negative r. So remember on the polars you can go backwards. But then instead of this angle, we're going to figure out this angle. So basically we're going to add or subtract pi. I'm going to, let's see, I'm going to steal my notes. I'm going to add pi. Which I think I already did this. Or not. Maybe I didn't. I don't think I wrote that down. And I don't have a calculator anywhere. So whatever that ordered pair was, I have this new theta. I don't know what I did. I didn't write anything down. None of it makes sense. Okay, I'm going to move on. Let's try another one from scratch, because apparently I did a bang-up job there. All right, 2, negative 2. Now, I know that this is a 45, 45, 90 triangle. So I think I kind of already know what's going on here. I'm going to go ahead and find the r by using our formula. So let's see, what is that? Square root of 8 plus 2 squared plus 2 squared. Oh boy. Come on, pen. All right, 2 squared plus 2 squared. The square root of 8, which of course is 2 squared to 2. So I kind of already knew that because it was a 45, 45, 90 triangle. Duh, Abruzzo. Now let's talk about theta. Well, I don't really have to do inverse tangent because I know that this angle here is 45 degrees, or if you want radians, it would be pi over 4. It does say right here they want radians. So this reference angle is pi over 4, but I need the angle between 0 and 2 pi. So they need this angle here, which would be 7 pi over 4. Right? Maybe, maybe? Yeah. Now, it does say find 2 polar coordinates. So, I have no problem with this answer. 2 squared to 2, comma, 7 pi over 4. Let's think about another way that we could describe that polar. So what if we went to this angle instead, and then we backed up 2 squared to 2 units. So this is, what is that, 3 pi over 4? So instead of going positive 2 squared to 2, let's back up 2 squared to 2 and say using an angle of 3 pi over 4. So we're kind of synthesizing a few ideas from polars together. So that's fun. All right, number 6, 3, 5. Right here. All right, so a little Pythagorean theorem action, and we get 9 plus 25, so it's the square root of 34 for the r. And then our theta is inverse tan of 5 over 3. When I type that on the calculator, if I'm in radians, which is what my calculator was when I typed this, I got 1.03 for my radian measure. So that would be an accurate polar coordinate. It would be square root of 34, comma 1.03 radians. Now, if I want the other one, I would just simply add half a rotation, so add pi to that. And I would get, what angle would that be? Let's see, I should be able to do that 4.17 approximately for radians. But remember, I need to back up to here. So instead of going positive square root of 34, we'd have to back up square root of 34. That was fun. All right, almost out of time. Oh, they crossed all this off. We're not doing any of that this year. That's exciting. On your notes, the next thing they discuss are a couple of final questions there at the end. I don't know why that's crossed off. We can do that one. I think we have time for that. Let's see. Oh, no, we don't. All right, the polar coordinate for the point and rectangular coordinates. So they want you to do a little converting. First thing I would do is I would find r, which would be the square root of 9 plus 9, so that's the square root of 18, which is 3 square roots of 2. So, not you and not you, it's one of these two. Let's figure out which angle they're referring to. Well, I'm just going to sketch that. Negative 3, 3 would be down here. So does it make more sense to say 5 pi over 4 or pi over 4? And since they're both positive square root 3 roots of 2, not going backwards, H is our answer. I like multiple choice questions because you can kind of cheat your way through them a little bit and not finish the question. So here they want you to go back to rectangular. So r is 4, and if I think about my cosine of 150 and my sine of 150, let's see, cosine is negative square root of 3 over 2, and sine is positive 1/2. So r times the cosine, comma, r times the sine would give me negative 2 square roots of 3, comma 2. Boom, right there. And then yes, this one is crossed off on your paper. All right, sorry, kind of bumbled through part of that lesson, but that's what you get. Good luck.